So I'm David J. Flores from CS 109, Winter 2020 class. This is the extra credit project that I'm submitting. My whole idea was to look at the U.S. Wealth distribution and the income distribution and the great inequality therein. So what I wanted to do was build an economic model that would have individuals with wealth and income and have it fluctuate through time and see if I could push it towards great equality or start with great inequality and push it towards great equality. So some of the variables I had in mind were wealth, income, of course, and I wanted to have expenses every year. I wanted to have taxes every year. I wanted to have voting that could possibly be affected by one's wealth, and I wanted to have taxes that would be affected by the voting, right? So taxes could be affected by voting, and then voting could be affected by wealth. The tax would include taxes and then tax breaks, of course, to simulate something like social welfare and corporate subsidies and things of the sort. And then other two variables I had in mind were two luck variables, one Bernoulli distributed, which would increase your income or decrease your income based on the rarity of your Bernoulli variable. And then a Poisson distributed variable where an individual would, in the simulation, have a product that they could sell to a binomially distributed amount of individuals in the society, thereby make money from everybody else that's in the society, or well, a binomially distributed amount of people. So without further ado, let's look at the model. I use NumPy, Seaborn, Matplotlib, Pandas, SciPy, and just other techniques that I learned in CS109. And I want to cite all the data that I used. I used a lot of government websites. I used the census. I used the Department of Health and Human Resources. I used Forbes. I used several organizations such as Statista and Seeking Alpha and EquitableGrowth.org. I also used the Urban Institute organization, and all of these provided me data so that I could talk about income inequality and make my model. So for starters, the first data I processed was the distribution of household income. The Urban organization had a lot of data on the percentiles from 1963 to 2016 in select years. So I just processed the data, and this is the distribution of data in 2016. The majority of people have somewhere less than like $100,000, and then there is 1% of families holding about $10,400,000 in wealth. And then these 4 bits of code over here are just processed to show the reader how much wealth changes for different groups of the population. So for the top, they went in the last 2 years, 2013 to 2016, from 8 million to 10 million, about a quarter in the jump. And then the top half went from having about 13,000 to 18,000. The bottom quarter went to having nothing to still nothing, and the bottom fifth was struggling just as well. This is merely exposition for the first half, just showing the degree to which income inequality is a problem to justify the importance of the model. Then I processed a lot of tax data. I used the tax data for 2013, 14, and 15 to calculate the rate of change in the tax brackets per time, and then reverted back to 1989, which is a year I wanted to start working with so that I could work towards the present year and see if starting with inequality I could get us to equality, or if it's starting with equality I could get us to inequality. I did not use the tax bracket for 1989, the year I want to work with, because in 1989 there were only 2 tax brackets, and I just don't think I need to argue why that was a bad idea.